Alright, welcome back into talking about lines and triangles on this unit. This day we're going to be doing some more proving triangles congruent. Really, this is just kind of more review about proving, just getting you more practice on it. This is our first example of the day. On this problem, we've been given that segment LN is perpendicular to segment KM. I've gone ahead and indicated that with right angle marks. We've also been given that these segments KL and LM are congruent. So now we're actually going to take a look at why these two triangles are in fact congruent. Because I've already got something about angles, I'm going to go ahead and scratch side, side, side. Most likely not going to be that. And now I'm going to kind of move through the rest of them and see which one it is. While I'm at it, a lot of y'all are getting used to seeing reflexive property here. This is a common side, so I'm going to say that segment LN is congruent to segment LN. And that's by reflexive property. And I'm going to go ahead and mark that on my diagram. And as I look at it now, I've got two pairs of sides now. So I'm going to go ahead and scratch angle, side, angle. Probably not going to be that since there's two pairs of sides, and angle, angle, side. The reason why I haven't scratched hypotenuse leg yet is because there is a right angle there, but it also might be side, angle, side. So let's take a look at this one. And in this case, the pair of angles, when I look at this angle, is not between the two sides. So it's almost like it would be angle, side, side, which you cannot do, except for this case, which is where it's a right triangle, and you are able to say that. So this is actually going to be by the hypotenuse leg theorem. So watch out for it. The hypotenuses are congruent, KL and LM. Also, a pair of legs is congruent, LN to LN. So I'm able to now prove what I was supposed to, that triangle KLM is congruent to triangle MLM. And this is by the hypotenuse leg theorem. And we're done with the proof. Alright, going to go through this process again really quick. Going to go ahead and start with my given. Going to go ahead and mark on the diagram that segment RU is congruent to segment TU. So I'm going to take a mark on each. So I have a pair of sides, well, not much else. I'm going to go right here to the fact that segment QS is getting bisected. Now be very careful here. Our segment RT is bisecting segment QS. Segment QS is the one that's getting split into two equal parts. So when I look at segment QS, those two equal parts would be segment QU and segment US. And that's by the definition of a segment bisector. Alright? And you see I've gone ahead and put that in as my statement too. Basically where I'd go now is I have two pairs of sides. So I know it might be side, 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 might be side, angle, side. Not going to be angle, side, angle. Not going to be angle, angle, side. I don't have anything about right angle here. Not going to be HL. So I've got it down to one of those two ways. Now looking at my figure, you should pick out these vertical angles here. So I'm going to go ahead and name those. That angle, RUQ, that's the one on the left, has to be congruent to angle SUT. And that's by vertical angles theorem. And I'm abbreviating a little bit since I'm running out of room rapidly. Alright, at that point, I know that's not going to be side, side, side. And in this case, it is side, angle, side because the angle is between the two sides. So now I'm able to say the triangles are congruent. So for my statement 4, that triangle RUQ is congruent to triangle. Now I gotta be really careful. If I used R first, T corresponds to R, so it will be TUS is how I named the second one, making sure that my corresponding parts match up. By the way, this was side, angle, side yet again. I mentioned that already. Now I'm ready to wrap up the proof because when you look at where segment QR is first and last. Segment ST, first and last as well. These are corresponding parts of congruent triangles are congruent. So I'm having to wrap up here at the left. This should go underneath here. That segment QR is congruent to segment ST, and that would be because CPCTC. Corresponding parts of congruent triangles are congruent. That wraps up this proof. Alright, now this is the first one that I've shown you where it's been overlapping figures. Really, there are two triangles that we're going to focus on. One of them is going to be DAC, that I just drew in purple. The other one's going to be BEC. And so they're kind of overlapping each other here. It's kind of a strange little quirk to this problem. So we're going to have to be really careful. The point that I'm going to really ignore here is F. I don't even really know why it's labeled, but it's not really going to come into play. I'm going to go ahead and mark down some given information that angle DAC is congruent to angle BEC. All right, and that segment DC is congruent to segment BC. And I did use different colors for a specific purpose. So the purple is a color that I'm using to represent triangle BEC with right now. And the red I'm using to represent triangle DAC right now. Alright, I've already got a pair of angles and a pair of sides, so it's not going to be side, 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 nor is it going to be HL, because I have no mention of a right angle anywhere, or anything being perpendicular. So, I'm going to go ahead and scratch off those two. It might be side, angle, side, it might be angle, side, angle, 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 side. Now, moving right along, it's really kind of tough to pick something out here until you realize there's a part in common. Y'all are so used to looking for segments that are in common, but really there's an angle that's in common for both of them. And that is angle C is congruent to itself in this case. And I can actually describe it as just angle C since it's the only angle there. So angle C is congruent to angle C. That's by the reflexive property, just like it was with segments. Just a really nice proof here because it's so different than the triangle proofs that you've seen already. So now that I've shown that, let's look at the purple triangle, this BEC triangle. The information that I have on it is two angles and one side. Not going to be side, angle, side. And the two angles do not include the side. The side is not between these two purple angles here. So that's angle, angle, side is our correct statement here. So I'm going to say that the triangles are congruent by angle, angle, side. And let's state these triangles. That triangle BEC is congruent to triangle. And I'll need to name the second one DAC to make sure corresponding parts match up. And now let's take a look here. What I was trying to prove is that segment BE is congruent to segment DA. When I look down here, first and second is BE. First and second is DA. They are congruent. So statement number 4, segment BE is congruent to segment DA. And that's by corresponding parts of congruent triangles are congruent. Hope you enjoyed today's lesson. I do have some practice for you to complete on proving. We do have the test coming up on Thursday. Make sure that you're ready for that. And that's the reason why we've been spending time practicing these proofs, because that's really where half of your grade is coming from on that test. You actually have to be competent with making these deductive arguments. All right, folks, let me know what questions you've got.